Welcome to the Deep Dive. Today, we're taking a deep dive into a stack of sources that touch on the ever-evolving landscape of technology and security. From new ways to measure risk to some unexpected privacy clashes, and even AI making some pretty surprising discoveries.
It really is moving fast.
Right. So our mission today, let's unpack these pieces of information, try to understand what's most important, and connect the dots on how they impact the digital world you navigate every day. Okay, let's unpack this.
Sounds good. The digital world is constantly shifting under our feet, isn't it?
Definitely.
And these sources, they really highlight that. You see changes driven by, well, everything from proposed new standards for security teams to big company decisions about user data.
Right.
Even these fundamental breakthroughs in how we find software flaws.
Absolutely. And let's maybe start with something pretty fundamental for organizations trying to stay secure.
Yeah.
How they actually, measure and prioritize risk.
Yeah, that's a core problem.
I mean, the sheer volume of new software and hardware vulnerabilities discovered every single year is it's staggering. We're talking tens of thousands. How on earth do security teams figure out which ones to fix first? They've got limited time, limited resources.
It is a massive challenge.
Yeah.
And the tools they currently rely on, like the Exploit Prediction Scoring System, EPSS.
Right, EPSS.
And the Known Exploited Vulnerability Lists, the KEV lists, they have their limitations.
Like what?
Well, EPSS scores can sometimes be inaccurate, and KV lists, well, by definition, they only include vulnerabilities already known to be exploited out there.
Ah, so they're reactive. They miss the emerging stuff.
Exactly. They might miss emerging threats entirely.
So there's a clear need for something better, something that helps cut through all that noise.
Precisely. And here's where it gets really interesting. NIST and CISA, key players in setting cybersecurity standards.
Yeah, the big names.
They've stepped in with a proposal, a new metric.
Okay, tell me about that. What's this new proposed metric called?
It's called the Likely Exploited Vulnerability Metric, or LEV for short.
LEV, okay.
They proposed it pretty recently, actually, in a technical paper published just May 19th, 2025.
And how does LEV fit in with EPSS and KA? Is it meant to, replace them?
No, not at all.
Yeah.
And that's a really important point from the source material. It's designed to augment them.
Augment, so add to them.
Yeah, think of it as providing another layer of intelligence. Its goal is sure to help security teams prioritize fixing things.
Right.
But also, crucially, to specifically identify vulnerabilities that might be underscored, that's terms I use, or maybe just overlooked by the current methods.
Underscored, meaning EPSS gave it a low score, but LEV thinks it's actually more likely to be targeted.
Precisely.
Yeah.
Or maybe it's not on the KEV list yet, but LEV flags it as high risk.
Yeah.
And fascinatingly, the paper suggests it even tries to measure the expected value that malicious actors might place on exploiting certain vulnerabilities.
Whoa, okay. Expected value, that's different.
It is. It's a step beyond just technical exploitability or whether it's being exploited right now.
So not just can it be exploited or is it being exploited, but is it worth exploiting from an attacker's viewpoint?
Right. That's the idea. And a key technical detail from the source is that this LEV metric is designed to be deterministic.
Deterministic, meaning?
Meaning its calculation is reproducible. It's not a black box guess. It uses specific factors like the date a vulnerability first got an EPS score, the present date,
Okay.
and a specific weighting system they've developed.
Got it. So it's rule-based, not some fuzzy AI prediction trying to guess.
Exactly. It follows a defined algorithm. Now, it hasn't been formally adopted yet.
Okay. It's just proposed.
Yeah, the proposal was just published. NIST is planning testing now with industry partners to see how it performs in the real world.
Okay, so what does this all mean then for, the organizations out there drowning in these vulnerability lists?
Well, if it works as intended, this isn't just another score to track. It's a potential way for your organization's security team to stop, maybe, chasing ghosts and focus on the vulnerabilities hackers are actually likely to value and target.
Makes sense.
It could make their limited resources much more effective, potentially save significant time, maybe prevent real breaches you might otherwise miss because you were busy patching something, less critical.
So better data to fight a smarter adversary.
That's the goal, getting smarter with prioritization.
That makes a lot of sense. Okay, so while security teams are potentially getting better tools for external threats, what about the tension inside the system, like between security features and user privacy?
Yeah.
That brings us to our next source. This situation with Microsoft Recall and Signal Messenger.
Oh, yes. This is a fascinating clash. It's all about user privacy at the app level versus OS functionality. We're talking about Microsoft Recall.
Recall. That was announced last year, wasn't it? May 20th, 2024.
That's right.
And the idea is it basically records everything you do on Windows, takes continuous screenshots so you can search back through your history.
That's the pitch, yeah. A native Windows AI search system. But, like you hinted, it's faced, well, significant controversy and security concerns since day one.
I remember hearing about that. Security researchers broke it pretty fast.
Reportedly, yeah. They were apparently able to bypass its alleged secure storage almost immediately after it was announced. And despite that huge pushback, despite the security issues raised, Microsoft announced just this April 10th, 2025, that they were still moving forward, still planning to include it in Windows 11.
Wow. That feels bold, given the privacy worries.
Yeah.
So how does a major messaging app like Signal react? They're big on privacy.
Signal took a very direct, very preventative stance. The source highlights that they've actually implemented a measure to prevent Recall from capturing screenshots of the Signal desktop application on Windows.
Prevent it.
Yeah, and by default.
By default. So you install Signal on Windows, and Recall just won't see your messages.
Correct. That's the intention. And what's particularly interesting is how they're doing it.
Okay.
According to the sources, they're setting a specific digital rights management flag, a DRM flag, on the application window.
A DRM flag. Like for movies?
Kind of, yeah. And get this. According to Microsoft's own documentation for developers, this flag ensures that the content won't show up in Recall or any other screenshot application.
No way. They're using Microsoft's own tool against Microsoft's feature.
Seems like it.
It's kind of cheeky. It does remind me, when you try to screenshot Netflix or something.
Exactly.
And the movie part just blacks out. Same idea.
It's exactly that kind of mechanism. It prevents the content from being captured at the system level using standard methods.
Yeah.
Now, it's important to note, Signal didn't make this like a mandatory block with no way around it.
Oh, okay.
They've actually published instructions for users who do want Recall to be able to capture their Signal messages. So you can turn this protection off if you actively choose to.
Okay, so they prioritized privacy as the default setting, but they still give users the ultimate control to override it if they really want to.
Precisely. Default secure, but user choice is available.
So what does this standoff, this kind of technical measure by Signal against a big OS feature, what does it tell us?
Well, it really highlights this ongoing tension, doesn't it, between OS developers who want, deep access to user activity for these new features like Recall, and application developers, especially in privacy-focused areas like secure messaging, who want to protect user data from being just automatically captured or indexed by the OS.
Yeah.
Signal's move here effectively puts the decision, by default, firmly in favor of privacy. It forces the user to make an active choice if they want to potentially expose their communications to this OS-level recording feature.
It's a fascinating point of conflict in modern computing.
Definitely, a real line in the sand.
That privacy clash is certainly noteworthy. Okay, speaking of things that feel almost like science fiction, this next story about AI finding security bugs, that's genuinely wild.
Yeah, this one really caught my eye too.
Let's shift gears and talk about the bleeding edge of security research.
Okay, so this involves a researcher named Sean Heelan, and he discovered a critical zero-day vulnerability.
0 day, okay. Always serious.
In the Linux kernel.
Wow, in the kernel itself. That's fundamental. But there's a twist here, right? That's not the whole story.
Here's where it gets really interesting. Heelan discovered this bug using OpenAI's O3 language model.
O3, like the large language model.
Yeah, and according to the source, he did it without relying on any additional specialized security tools or frameworks, just the language model and the source code.
Hold on, so the AI wasn't just like assisting him while he used other tools. The AI was the primary tool that found the flaw.
That appears to be the case, based on the source material. It's quite remarkable.
Wow, okay, what was the vulnerability?
It's identified as CVE 2025-37899, and it's a critical use after free flaw.
Use after free, that's a memory corruption bug, right? It can be really nasty.
Extremely nasty. It's where a program tries to use a piece of memory after it's already been deallocated or freed. It can lead to crashes, or worse, code execution.
And where specifically in the huge Linux kernel was this hiding?
It was located in the KSMBD module. That's the kernel's implementation of the SMB server.
Okay, for file sharing and stuff.
Exactly. And specifically within the handler code for the SMB logoff command.
And the risk. What could an attacker do?
So the source explains that under certain conditions, basically with concurrent connections hitting it just right, A user session object can be freed while another part of the code is still trying to access it. That's the classic use after freeze scenario.
Right.
And if an attacker can trigger this correctly, it could potentially allow them remotely to execute arbitrary code with kernel privileges.
Kernel privileges, that's game over, basically. Full control of the system.
Pretty much the highest level of access you can get. So he has a very serious flaw.
Okay, so a critical bug hiding in a core part of Linux found just by an AI. How exactly did the AI find it? Did Heelan just, feed it the code and say, find bugs?
Essentially, yes. The source indicates Heelan was evaluating O3's ability to reason about code. That was his goal.
Right.
So he gave it the KSMBD source code and asked it to identify vulnerabilities. And here's the key point. The model didn't just flag known bugs or, common sloppy coding patterns.
It found something new.
It identified this previously unknown zero-day flaw. And it apparently accurately described the underlying use after free condition and how it could actually happen.
That's a huge step. It shows AI moving beyond just pattern matching or generating code into actual deep code analysis and finding novel vulnerabilities.
It absolutely does. This is being highlighted quite rightly as a significant milestone in AI-assisted vulnerability research. The potential implications are, vast.
On a practical note, before we get carried away, has this specific vulnerability been fixed?
Fortunately, yes. The good news is the vulnerability has been addressed in recent kernel patches.
Okay.
So users running vulnerable versions of Linux are, as always, strongly advised to update promptly to mitigate that risk.
Good. Phew. So thinking bigger picture then, what does this AI discovery mean for cybersecurity overall?
Well, it really signals that AI is rapidly evolving beyond just, generating text for emails or making pictures.
Yeah.
It's becoming capable of highly complex tasks, like analyzing dense, complex code bases and finding these subtle security flaws that might evade human researchers or traditional automated scanning tools.
So it's not just a neat trick.
Not at all. This could fundamentally change how security vulnerabilities are discovered.
Yeah.
It could potentially speed up finding flaws, both for the attackers and hopefully for the defenders trying to patch things.
It adds a whole new dimension to that cybersecurity arms race, doesn't it?
Absolutely. A really powerful new tool entering the field.
Wow. These three stories, when you put them together, they really paint a picture of a super dynamic landscape, don't they?
They really do.
I mean, we've looked at new proposed metrics for security teams trying to measure risk more effectively, the LEV metric.
Then how a major app like Signal is actively defending user privacy against OS-level features like recall.
That OS versus app tension.
Yeah.
And we finished with this, frankly, surprising development of AI stepping into the role of vulnerability researcher, finding critical bugs in core software like the Linux kernel.
Yeah, they really show the different fronts in cybersecurity. There's the organizational challenge managing all those vulnerabilities.
Yeah.
There's the individual user's fight for privacy against these, ubiquitous system features.
Right.
And then there's this cutting-edge technological arms race between offense and defense, now with AI squarely in the mix.
We've definitely covered a lot of ground in this deep dive, from those quantitative risk measures to defensive privacy moves and, the surprising capabilities of AI. Thinking about all these developments, it really just highlights how complex staying secure and informed actually is today.
It never stands still, does it?
Not for a second. So here's maybe a final thought for you, the listener, to mull over.
Okay.
If AI, like we just discussed, can now find previously unknown critical bugs in core software like the Linux kernel, how is that going to change the race? The race between finding vulnerabilities and fixing them in the years to come.
That is the big question, isn't it? Something to definitely keep an eye on.